This lesson is going to be about horizontal projectile motion. What is horizontal projectile motion? Well, projectile motion is the motion in which an object moving in both the x and y, so the horizontal and vertical, while under only the influence of gravity. For example, cannonballs, fly balls, home runs, basketball shots, things flying through the air. If I shoot a gun, the bullet. Okay, so it moves in both the x and y direction with gravity acting on it. Now there's a couple of terms. We just went over projectile. Another word you might see is trajectory, and that's the path the object takes. For example, this dotted line down here shows the ball's trajectory. And range is how far the box or how far the object has traveled in the x direction. So the range is from here to here, just the x direction. For here, the cannon, here to here, this is the range. Okay, those are just some new terms that you might come across. Now, horizontal projectile motion has two directions. And just like when we're going up and down with two directions, we treat each direction independently. So this is a good picture to show you the different directions. The ball is moving in the x direction and the y direction. The x direction and the y. Okay, it's moving both ways. Now this is the key point up here that we're going to look at. For horizontal projectile motion, it initially is only moving in the horizontal. So it initially only has a horizontal velocity. Its initial vertical velocity, or y velocity. So its initial, I'm going to call that an initial y velocity. Let's write it a little bit differently. Velocity initial in the y direction is going to equal 0. Alright, so anytime we're dealing with horizontal projectile motion, a couple of key points. 1, your displacement down is negative. Make sure you remember to keep that negative. Otherwise, you're going to end up with trying to take a square root of a negative number, and that doesn't work. This is a key point. Your time up is your time across. So horizontal time is your vertical time. So it travels this way the same amount of time it travels this way. So your time is the same. So if you know your horizontal time, you know your vertical time. And that's a key point. You're almost always going to have to solve for time and then link them together. Your acceleration in the horizontal. Okay, so it can be AH or sometimes represented as AX, which is the horizontal acceleration, is equal to 0. Because the only thing causing it to accelerate is gravity, which is only acting in the vertical, which is why your acceleration in the vertical is still negative 9.81. Okay, so gravity is still acting, but it only acts in the vertical, and since we treat them independently, horizontally, nothing's causing it to speed up, which is why you get this curvy path, because you're going faster and faster and faster in this direction, but the same speed in this direction. So you're always covering the same amount of distance horizontally, but vertically you're covering more and more and more distance. So you get that curvy path. Your initial vertical velocity is 0. I talked about that. Initially, all your velocity is horizontal, so 0 is left for vertical. Okay, horizontal projectile. Horizontal is being the greedy child and eating all the cookie and leaving no cookie for vertical, or no velocity for the vertical. Let's look at an example. A toy factory makes wooden giraffes. As the toy leaves the conveyor belt, they fall into a box. If the box is 0.6 meters below the belt and 0.4 meters away, what is the velocity? What velocity do giraffes need to leave the belt with? Alright, so 0.4 meters away, 0.6 meters down. Well, let's fill in these numbers. Alright, so we know that it falls 0.6 meters. So we have a displacement in the vertical, because it's falling, of negative 0.6. Horizontally, it's going 0.4 meters away. So we have a horizontal of 0.4. And you see how I separated horizontal and vertical. Two different directions, two different sets of variables, VI, VF, ADT for both of them. Okay, now, we took care of all the numbers, but we don't have everything we need. So let's see what we can fill in. The vertical is really where we can fill things in a lot. We're starting with an initial horizontal velocity. So our initial velocity is 0. Our acceleration is negative 9.81. Okay. Now, we're looking for our initial horizontal velocity because we're looking for the velocity that the draft needs to leave the belt with. That means we need to know 3 things over here because we want to know 1. Now, because our acceleration is 0, VI equals VF. So VF would not be much help in the horizontal. It would be absolutely no help unless we were given it. Okay, so we won't know VF. So we need to know A and T. We do know A. Our acceleration in the horizontal, because the only thing acting on it is gravity, our acceleration will be 0. Time, we don't know, and there's no way of inferring time. But time is the one thing that's the same on both sides. So if we can find our vertical time, we can find our horizontal time. So let's do that. Over here we have VF, A, and D. We're looking for VI, A, D. So we use the equation without VF. D equals VIT plus 1/2 AT squared. Negative 0.6 equals VI is 0 plus 1/2 A, negative 9.81. T squared, we're solving for T. We get T equals 0.35 seconds. Now we get that because we multiply 1/2 by 9.81, simplifying it down. Our negatives cancel, and we get T squared equals 0.122 after we divide both sides by 4.905. So just the algebra gives us this. And we end up with T equals 0.35. So if we know our T vertical is 0.35, then we know our T horizontal. Now that gives us enough information on this side to solve for VI. We know T, D, and A. VF is the one thing we don't know, don't want to know. So we use the equation without VF, which is the same equation. Only in this case, we're solving for VI. So D equals VIT plus 1/2 AT squared. 0.4 equals VI, which we're solving for, times T, which is 0.35. Now this whole 1/2 AT squared, well, our acceleration is 0, which means this whole thing goes away, because it becomes plus 0. So we have to undo what's being done to VI, divide both sides by 0.35. So we get 0.4 divided by 0.35 equals 1.14 meters per second. And that's our answer. Alright, so with these kind of problems, you almost always have to find time, because time is the thing that links them together. So you'll be able to solve for time on one side of the equation, solve for time, and then find something else. Usually that's the way it works. It's a map. You find time, you use that to find something else. So it's a 2-step problem usually. Now, an interesting point. If you fire an arrow horizontally and drop another arrow from the same height, they land at the same time, which makes sense because VI, VF, ADT. Horizontal has no effect on the vertical. So as long as they have the same D and the same VI, they're going to have the same A, which means they'll have the same T. And you can actually check it out and try it out. The two directions are independent, so it doesn't affect each other. You can shoot a bullet and drop a bullet, and as long as you shot that bullet with an initial horizontal velocity of 0, so they have the same initial vertical velocity. As long as they have the same vertical velocity, they will fall at the same rate. Because it doesn't matter if you change this velocity, as long as you don't change this velocity. Alright, that's all for the lesson. Don't forget to complete your homework. Good luck.